All right, let's jump right into this explainer and tackle one of the most misunderstood yet absolutely incredibly powerful architectural patterns out there, the visitor pattern. Look, if you've ever felt the sheer pain of trying to add a new feature to an existing, stable code base, only to watch your code fracture into a million scattered pieces, yeah, you are definitely in the right place. We're going to completely demystify how this pattern actually works, specifically in Go, and show you how it can literally save your architecture. Let's get to it.
So, imagine you've built this thriving e-commerce platform. You've got 3 totally stable product types: rice, pasta, and fridge. They're well tested, they're sitting happily in production, everything is great. Then product management suddenly drops a bomb on you with 6 brand new business requirements all at once. You now need to calculate total cart price, print a product catalog, generate a discount report, apply seasonal taxes, check expiry dates, and export the whole shebang to CSV. If you use the naive approach, just adding a new method to every product struct for every single new requirement, do you know what happens? You end up writing 18 scattered new methods, 6 requirements across 3 product types. And if you add a 4th product tomorrow, like a microwave, you've got to remember to go back and implement all 6 of those methods all over again.
Here's the absolute nightmare scenario. Adding a new type or a new feature forces you to modify everything. Every new feature touches every type, and every new type has to implement every feature. You're risking massive cascading regressions in your production code. So the holy grail question for software design really becomes, how do you extend the system without touching every existing struct? How do we break this n times m explosion of code?
To solve this, here's our roadmap for today. We'll hit the code explosion problem, the visitor solution, the mechanics of double dispatch, some really important Go embedding gotchas, the architectural trade-offs, and finally, exactly when to use this pattern.
Starting with Section 1, the code explosion problem. Let's see how our initial instincts as developers often lead us right into this trap. The contrast here is just striking. Over on the left, picture the naive approach. Your rice struct and your fridge struct suddenly have to know about seasonal taxes and CSV exporting. Just visualize that code structure for a second. Why on earth should a fridge struct contain formatting logic for a CSV file? It shouldn't, right? The visitor approach on the right completely shifts the paradigm. Instead of scattering tax and discount logic across your product structs, you centralize that algorithm into one isolated place, a brand new visitor struct. You are literally separating the algorithm from the objects it operates on.
Which brings us to Section 2, the visitor pattern solution. What's really fascinating here is how it completely flips our approach to extending code.
You've probably heard of the open/closed principle, right? It's the O in solid design. It states that a software entity should be open for extension but closed for modification. It sounds great in theory, but how do you actually pull it off? Well, the visitor pattern is the practical, definitive answer to this principle when you're dealing with stable type hierarchies. Say you want to add a new tax calculation. You do not open up the rice struct to modify it. You leave it closed. Instead, you extend the system by adding a new tax visitor. 0 changes to your existing types. It's beautiful.
If the code sounds a little abstract right now, think of it like this postal inspector analogy. Imagine a post office with letters, standard parcels, and refrigerated goods. When a postal inspector comes around, the package itself doesn't need to know how to inspect itself for contraband or weigh itself. The package just opens the door. It accepts the inspector. The inspector already holds all the specific logic for how to check a letter versus how to check a refrigerated good. The logic lives securely with the inspector, not the package.
Moving to Section 3, mechanics of double dispatch. The crucial point here is understanding how the system actually knows which logic to apply without falling back on massive, ugly if-else chains.
Let's break down the implementation using our e-commerce cart so you can really vividly picture the code flow. You just follow these exact 4 steps. First, define 2 interfaces, a visitor and a visitable. Second, create your concrete types, like rice or fridge. Third, and pay attention, because this is the magic step, each of those concrete types implements an accept method. All this method does is take in a visitor and essentially say, hey, visitor, come on in and visit me. Finally, step 4, you write your actual visitor logic, implementing specific calculation methods for each product type it visits. This back and forth communication is what we call double dispatch, and it's incredibly important in Go. See, because Go lacks method overloading, meaning you can't just write 5 different visit methods with different parameter types and expect the compiler to magically sort it out, we rely entirely on this double dispatch mechanic. The operation that ultimately runs depends on 2 things: the type of the visitor, like a tax visitor versus a discount visitor, and the type of the visitable object, like rice versus fridge. The visitable object calls its accept method, which then explicitly hands itself back to the visitor's type-specific method. It's like a beautifully choreographed handshake. Okay, Section 4. Go embedding and visitors. Let's look at a massive implementation detail, a huge gotcha, that you will absolutely hit in production if you aren't careful.
In our e-commerce example, you might naturally create a generic product struct and embed it into your fridge struct to share common fields like ID or price. But remember, in Go, embedding is not inheritance. Go uses structural typing. This means even if your base product struct has an accept method, your fridge struct must explicitly implement its own accept method. If you just rely on the embedded one, the visitor is going to think it's visiting a generic product, not a fridge, and your type-specific logic will completely break. So golden rule, always implement the accept method directly on the concrete type.
Section 5. The ultimate architectural trade-off. Look, every design pattern has a cost. There are no silver bullets in software engineering. Let's see if Visitor is actually the right fit for your system.
I really want you to burn this matrix right into your memory. This is your cheat sheet. The visitor pattern optimizes purely for adding operations. It is absolutely perfect when your types are stable. Think of the nodes in an HTML document, those rarely change, but you are constantly adding new operations, like new ways to render or parse that document. However, if your system frequently introduces new data types but the operations stay mostly the same, the visitor pattern becomes a massive burden. Why? Because every single time you add a new type, you have to go back and update every single visitor interface and struct in your entire codebase. So always ask yourself, what changes more often in your domain?
Finally, Section 6, when to use visitor. To wrap up the technical breakdown, let's look at where this pattern actually lives and breathes at scale in the real world.
You are honestly probably using this pattern every single day without even realizing it. The most canonical example? Go's very own compiler. It literally uses the visitor pattern via go/ast.Walk to safely traverse syntax trees. That is incredible. The language itself relies on the exact pattern we just learned to inspect your code without modifying the code structures themselves. Static analysis tools and linters use it too. Document renderers use it. You might have one single document tree, but you have an HTML visitor, a PDF visitor, and a Markdown visitor. Tax and pricing engines use it to apply complex, jurisdiction-specific rules to a fixed set of cart items. It is literally everywhere.
And this brings us right to the core philosophy of the visitor design pattern. Separate algorithms from the objects they operate on. If you can master this philosophy, separating your complex business logic from your stable data structures, you are going to build incredibly robust, extensible Go applications that can grow without turning into a tangled mess. So take a hard look at your codebase today. Ask yourself, what algorithms are tightly coupled to your structs right now? And more importantly, what algorithms are you going to extract using the visitor pattern today?